Okay, before we dive into the naive Bayes classifier, I just want to refresh your memory a little bit on the classification challenge as well as on Bayes rule. Remember the classification challenge, the way that we define it is that we have a certain data set D. This is the data, so we have x1, y1 to xd, yd. The x's are the features and give you the dimensions of the problem, and the y's are the labels. The fact that the y's are given makes it a supervised learning problem. Now this data set D is drawn from a certain distribution, as we call it in statistics. So D is drawn from a distribution that gives me the label given D. The problem is this distribution is not known. If we would know this, our problem would be solved. So given X, basically what is the label? That's what you want to have. That's the distribution. Well, if I have the distribution here, I have the probability of Y is 1 or 0, and here I have your X's. And I have these blue dots all here. These are my training points. Now when I take a point X here, any point X, I can easily see that this point X is going to be Y equal to 1. Okay? So that shows if I have this probability distribution, I can solve the classification problem. So keep that in mind, it's very important. Now, let's go to Bayes rule. I explained Bayes rule in the statistics refresher. It's a very important formula for machine learning. Basically what Bayes rule does, it links the prior to the posterior. Let me explain. The prior here is the probability of an event A while B has not occurred. Whereas the posterior is the probability of the same event A, but now B has already occurred. So you can actually map the influence of an event B on the event A. So it links prior to posterior. It also links A given B to B given A. Can be important because this is the problem that we need to solve. Given the data, what's the label? But if we could solve, give the label, what is the data, could also be an option. Because if I know one, I can calculate the other. Now there is a way to, maybe there's a way to estimate the probability of Y given D. Maybe we can estimate. And this is where MLE, maximum likelihood estimation, as well as map A posterior, that's where they come in. So can we estimate this P of Y given D? And let's take an example. Let's take an example where we have 10 coin tosses. And here's the data. We have head, tail, head, tail, head, and 4 times tail. Can I derive the parameters of the distribution from the data? Well, a coin toss, we know it's a Bernoulli distribution with a parameter P. P is the chance, in our case, for example, the chance of having heads. Then we know that the chance of having tails is 1 minus the chance of having heads. So if I try to calculate P here, and P is the chance of having heads, then we have, so I have 10 tosses, so I need to divide by 10, and I count 4 heads, so equals 40%. It's not a very good estimate, right? It should be 50%. The reason why we're so far off is probably because your data set is too small. So data set is too small. So I can draw the formula for maximum likelihood estimation. We call it argmax. of theta, yeah, of d comma theta, yeah. So in our case, the theta is p, yeah. So what p gives me the highest chance of getting this outcome for the data? That is basically the question. So theta is here the parameter, parameter of distribution. You can have more than one. For a Gaussian distribution, for example, we have the mean and the variance. Yeah. Okay, so it's not d slash theta, it's d comma theta, because strictly theta is not a random variable. Theta is a parameter. And the people that are supporters of MLE will tell you that it's not a random variable because there's no distribution you can draw data from. Okay? Okay, so that is one way. The second way is map a posterior. And in map, what we do, we consider theta as a random variable. Yeah. So the probability of how will we calculate theta? Probability of theta given d is the probability of d. Sorry, that's base. D given theta times probability of theta divided by the probability of d. So this is base rule. Okay?